modeling tutorial, so it's going to get a little bit more advanced than the last kind of beginner tutorial, but it'll go through kind of my process in modeling, which I'm sure is familiar with a lot of landscape architecture's process. So just to go over what we covered in our first tutorial, if you happen to miss it, I would highly recommend going back and looking through that tutorial and walking alongside it before kind of diving into this, because it covers a lot of the basics like interface navigation and just a series of frequented commands. And this session, we are going to cover a couple more commands that I neglected to discuss in the first one due to time constraints. And then we're going to go into kind of how to get topography. Then we're going to do some NURB modeling, which is basically the poly surface that's created through a series of control points. And when you will utilize NURB modeling, I'll briefly go into Grasshopper because that's going to be a critical component to mesh modeling, but then we'll go into mesh modeling and when to utilize that. And then we'll introduce you to selection filters, work session, and then we're going to get into modeling an urban park, modeling a play feature, and then you'll be able to see how quickly you can go from Rhino to a rendering software like Enscape or Lumion, and we'll just share that with you quickly. So I'm just going to go ahead and dive into Rhino here. So I'm gonna just open up a basic document. This is I'm going to check the units by typing in units, and we are in feet, and we are in decimal, so we're all good there. I'll first kind of show you all the array command and the intersect. So if you remember last session, these various options down here, design aids, I'm just going to turn grid snap on, and I'm going to make a line that's 50 feet by typing in 50, pressing enter, and then I'm going to restrict it to the Y axis and just click to get that point in, and then I'm just going to spacebar to press enter. So for array, if you type in array, you can see that there's a series of arrays that you can do. You know, you could just do your standard array. You can select your objects. Remember to utilize these prompts, press enter. I'll do 10 in the X direction, 10 in the Y direction, none in the Z direction, and then I'll make the spacing 10. So as you can see, you get 10 in the X direction, and if I make this 60, you'll get 60 spacing in the Y direction, and that's just a standard array. I'm going to go ahead and array polar. And what that does is you're arraying around a single point. So I'm going to select the center, and I'm going to say we want 40 items, and then first reference point, second reference point, and that's basically arraying that in 360 degrees, and there's 40 separate lines. So that's just an example of a polar array, and I can show you how this will become useful here. If you caught the last session, you can see, or you know that I like to model shade structures and pavilions. So I'm going to do something like that quickly here. So I'm going to just make this circle diameter of 30. I'm going to copy that Control C, Control V. I'm going to move this up 30. Control C, Control V. Move that up 10. Control C, Control V. Move that up 20. So you have a series of circles in the Z direction. From there, I'm just going to offset this circle. I'll offset it by 15. Set this by 8. And I'll leave the top one as is. So we covered loft on the last session, but I'll just run through it again here. So you can select these curves to loft. They're all pointed the right direction, kind of at the same position along the x-axis, which is good. And as you can see, I'll turn this to shading. It'll loft this shape. And not entirely what I wanted. So I'm gonna actually just delete this, pull this up, and I'm gonna run that loft again. There, that's something relatively neat. So that's how, you know, you're lofting that poly surface through those curves. So that's just an example of a loft again. And now I'm going to select a new layer. By double clicking that layer, I'm going to extrude these curves. And I'm going to just extrude them in the Z direction. So they go through this object, as you can see in this window here. I'll select one more new layer and I'll show you all intersect. So it says select objects to intersect. I'm going to select that shape I just lofted. I'm going to select all these. And as you can see, it intersected each of those planes within that shape, which gave these network of curves here. So I'm going to go ahead and turn these things off. So here's just those intersections shown. And then I'll do one last command to kind of make this structure a little bit more sound and able to stand up. And that's going to be with contour. So I'm going to select this object to contour. I'm going to select this point, and then I'm going to select a perpendicular point, and I am going to make this distance between contours 10. Whoa. And as you can see, that axis was not directly in the Z direction, so it took it and did it sideways, which is kind of neat, and that was unintentional, but I'm actually going to change that layer, change those to a different layer and turn it off, and I'm going to run that contour command again. I'm just going to select here in the Z direction and make those contour intervals 10. So as you can see, if you contour on a wonky axis, you'll get contours that go on a different direction, which is you could utilize in several ways. But I'm going to go ahead and just work with these, and I'm going to take these, actually change into a new layer. So then you have your kind of structure, and we discussed last week that you can select objects through your layers, and I'm just going to go ahead and do that now. Work on this layer, and I'm going to go ahead and type pipe, and I'm going to make this radius 0.25. So as you can see, you have this cool structure that you've just developed utilizing a couple simple commands: array polar, loft, extrude curve, and contour. And now I'm actually going to show you what this would look like if you utilize that accidental contour, which I think may make this a cooler or structure. Yeah, as you can see here, you now have this sideways tilted plane. So this is just another tool to your toolkit when you're kind of designing, and just a frequently used command that I always utilize. So just to go back to the agenda, we've covered the array and intersect. We'll go into generating topography. So there's a lot of different ways you can get topography. If you're working on a project, you'll likely get it from your civil or from your surveyor. Sometimes you'll get a surface from your civil engineer that has it. You could get it from LiDAR or GIS. And there's another way that I'm going to show you. And this is, it's not 100% accurate, but it's actually really not that accurate. But we're just going to go ahead and use it for an example. I'm going to open up SketchUp. This is the one time I will utilize SketchUp because they have a geolocation feature. I'm going to go ahead and just add a location. And we'll go into Denver. And I'm just going to pick a random location that I believe has topography. This looks like Bear Creek Lake. It looks like there's some topography adjacent. So I'm going to select this region. And I'm going to go ahead and grab this, click import. And, I would utilize this technique if I was, in school, or if I was coming up with maybe a graphic for a competition where we haven't received any topography yet. But if you go to geolocation, show terrain, you can see that this this imported terrain does have topography linked, shown by showing that elevation. And I'm just going to save this on my desktop. And I am going to call it Denver terrain. All right, so from there, I'm going to close out of SketchUp because that's all we need it for right now. The nice thing about Rhino is it works well with other modeling software. So you can go ahead and import that terrain into Rhino directly. And the standard import settings are fine for this. So I'm just going to click OK. And as you can see, it comes in with a couple pieces of terrain. I'm going to delete this flat one, but now you can see that this terrain lives in Rhino. It's got a series of Z values. It came in as a mesh, so each one of these triangulations is a flat surface. And what I'm going to do from there is I'm just going to run one of my all-time favorite commands, which we've discussed earlier, is contour. I'm going to select a base point. And I am going to make sure I'm contouring in the Z direction, which you can see on the perspective view here. And I'm going to make this interval 1. And as you can see, it just generated all those contours from that surface that we got from SketchUp. I'm going to delete that. And here is just a series of contours. They all have distinct Z values. If you go into your properties and click details, you will see that it is an open polyline made by 155 points. And this is the X axis, this is the X coordinate, this is the Y coordinate, and this is the Z coordinate. So it's 73 feet in the Z direction, or 73 feet, you know, in your surveyed topography. So it all has the unique Z value, which you'll need to make this surface. So there's a couple ways to make a surface. There's the NURB, or the poly surface, and then there's the mesh. I'll just go ahead and share how to make a NURB surface. I utilize NURB surfaces when I am not being 100% precise. If you're in schematic design, or if you're working in a college course, NURB surfaces are fine to use. They're generally a bit easier to work with than mesh surfaces, but again, they do not have that accuracy. And to make a kind of just a NURB surface on this, there's a couple ways to do it. One way is doing it through these individual lines, and another way is through the points. So we'll start with just the contours. I'm going to go ahead and select all of them. I'm going to type in patch, and I'm going to show you kind of this setting in multiple ways. So the sample point spacing, I usually keep at 0.5, stiffness at 2. But if I turn this down pretty low, the U and the V spans, that's essentially the grid that the surface is going to be made of. So it's going to be 10 grid lines in the X, 10 grid lines in the Y. And I'm going to just click OK. As you can see, it patched that surface to those polylines. But you can notice that it's not 100% accurate because it's interpolating that surface based on those lines. So it's not 100% accurate as a surface. I'm gonna go ahead and turn that off. So that was just, you know, you can see the 10 grid lines in either direction. Another way to do it to get a little bit more accuracy is to select it all, show your points. And before I get into that, I'll show you selection cycling or selection filter. So if you type in selection filter, it'll pop up this bar down here. And this allows you to select the things that have been checked. So if I deselect curves, it won't let me select curves. This is a nice feature because if you are working with a pretty complex model and you just want to select a certain object or a certain object type, you can do that with this selection filter. So I'm going to go ahead and turn on points, and then I am going to type in extract PT for extract points, and then I'm going to select all of these points to extract. So now, instead of just being able to view them with this show object control points, these are actually physically in your model space, and these are actually objects that you can select out. And what you can do from here to get a more accurate surface is you can run that patch command on these points as opposed to those lines, and you can see between these two surfaces and the contours, they've created a different result. Some parts are a little bit more accurate than others, but I would always suggest modeling your surface based on those points because it does increase that accuracy. And a way to get it really close to your contours is if you were to select all these again, type in patch, and then change this UV spans to a higher number. This will create a more dense grid. It'll also take some time to process because it's just making that surface on a smaller grid point. So it's just taking a lot more processing time. But I will, if I'm trying to get a highly detailed surface, I will turn it up to that frequency, because you can see there's now 100 by 100 of those grids. And if we look at our topography, you can see that it's not 100% exact, but it's a lot closer than it was before when the sample point spacing, or when the U and V was a smaller number. So that is just how you can go ahead and make a NURB surface based on a series of contours. Again, it's a little easier to manipulate than the mesh surface, and it does, you can go ahead and turn these points on and start manipulating your surface with these points. But again, it's not as accurate as the mesh. So I'm going to show you a mesh, how to make this into a mesh, or how to make a surface with a mesh. And that is going to be utilizing Grasshopper. So I'll just do a brief introduction. I know there will be a tutorial on this in the future, but what is Grasshopper? It's a parametric modeling tool. It's a visual program interface inside of Rhino. You can download it for free, and it allows you to drag components, which are shown here, onto a canvas, and you can connect those components. So it's a way that you can model something, and then it can become changed very easily by adjusting sliders and different components. And that allows you to kind of adjust your output through Grasshopper instead of having just to remodel something from beginning. So I'm going to go ahead and open Grasshopper by typing in Grasshopper. And this is going to be extremely basic. There's only two components that we're going to need to make this mesh. And I'll show you that now. So once you're in Grasshopper, you can see kind of the canvas. Here's like your series of components. You can also type it in. So what we showed earlier was generating a surface based on points. So we are going to need a point, PT, and then you will type in the command Delani mesh, which puts this component on that programming board. From there, you can see that it'll need points for triangulation. So what you can do is plug your points into points. From there, I'm going to turn this off and turn my points on. You can go ahead and select all these, right click, set multiple points. And as you can see, Grasshopper has triangulated that Delani mesh through those points. From there, I'm going to put this on layer. I'm going to go ahead and just bake this. And I'm going to bake this on layer 5, which means it turns the Grasshopper script into an actual model. So I'm going to turn off these points. I'm going to turn this preview off. And as you can see, it took all those points and triangulated these this mesh. So if you turn on your contours, you can see that this mesh is really tied to all those contours, so it's very accurate. Meshes are a little bit harder to use when modeling, but you can also, like with the NURB surface, you can adjust these points to change that surface. So when I'm modeling for a project, I will make sure that the topography, the surface that I've made is ready, is like fully fleshed out, and it's what the topography we want to be shown is shown. So I always start by making a nice quality surface before I get into any of the site modeling. But I'll show you kind of the accuracy difference between the two. So I'm going to just go ahead and delete that. I'm going to turn these points on. I'm going to go to the top view and say I had a building, and I'll just make it in a new color. Say I had a building, and this is kind of the building pad that it sits on. I'm going to go here in this view, and you can see that it's on, it was drawn kind of on 0, 0, but I'm going to move it up 10 feet. So you wanted to move that pad up 10 feet. Actually, I'll move it up 20. So then say this is your building pad and you wanted this to become flat. You can go in from a top view, and you can make sure your points are set to select, and you can go ahead and just grab these points kind of around your building pad. Then what you can do is, if you hop in your perspective view, you can do set PT, and you can set your points in the Z direction to that building pad. And as you can see, all of those points have now been raised to that building pad elevation. I'm going to turn this off. I am going to just make a new layer with a different color. I'm going to open Grasshopper again. I'm going to set multiple points, press enter, and as you can see, Grasshopper took that information and is making a surface from it. So I'm going to bake that on a new layer. And as you can see, this, by elevating those points to that building pad layer, you have just set all those points to that right elevation, and it's kind of just taken those points and connected them directly to the adjacent surface. This is nice when you're working on like residential projects and stuff, when you know that your building is going to be set at the right the right elevation, and you need it to be very accurate if you're bringing in a architect's model, and the client wants to see what their view is going to be like, and view is maintained. So I always use this in like DD, CD, when you're really fleshing out kind of those details. So you can also do that with NURBS. And if I go ahead and make a new layer and I select all this and type patch, that here. I'm going to turn off those points. You can now see that that building pad has been patched into this surface. But notice that there's that line isn't completely visible, it's actually underneath the surface, it's because that NURB surface was being interpolated from those points. So as you can see, you do lose some accuracy with the NURBs, but it does kind of take it and interpolate those side slopes for you. So that's, you know, if you're working in SD or you're working on a school project and you put your building down a little bit, you know, it'll sit on there, but it won't be 100% connected. So that's just the difference between those two types of surfaces. Again, NURBs are a little less precise, a little easier to work with. Meshes are fairly more precise and a lot harder to work with. But if you wanted to change these, you can always turn your control points on. You can selection filter only points. You can grab these series of points. You can run your set PT command, and then you can change those to that building pad. So that's a way you can adjust those meshes. So like I mentioned before, I always try to get this surface to be how I want it before I start to do my site modeling, and we'll dive into why that's important here in a moment. So to go back, we've covered generated biofeed NURB modeling, the grasshopper intro, mesh modeling, selection filters. So now we're just going to go ahead and close this file out. And I'm going to open some of that information that I've shared in the chat, some of those files that I've shared in the chat. So I'm just going to go ahead and open site massing, site line work, NURB surface. So as we covered in the first tutorial, you always want to start with your site line work, with your 2D line work, and this can be in you can do this either in Rhino or CAD. I'm going to show it from CAD, but we'll just open our NURB surface file. As you can see, it's got the terrain that we were just working with already in here. It's a NURB surface, so it's a series of curves in between these grid points, as opposed to triangulated faces. And I'll show you something really neat that I use all the time now, and it's called work session. If you're familiar with AutoCAD, it's XREFing in Rhino. If you type in work session, it'll open this work session manager component, and I'm going to go ahead and click attach, and I'm going to change this to AutoCAD. And if you're working in AutoCAD, I always like to draw my information in CAD because you can get it pretty accurate with fillets and curves. And so I usually start with CAD and then bring it into Rhino, but I'm going to go ahead and just open that. Then I'm going to close this. And as you can see, it brought in that CAD line work directly into my model. When you're working in CAD from a survey, you'll see that it always comes in real world coordinates or surveyed coordinates. So it's not going to be close to Rhino's, 0, 0, 0 plane. So it'll actually be in your real world location, which is good if you're running analysis on these things through Grasshopper or sun shade studies, etc. So the cool thing about work session is this comes in kind of grayed out, so it doesn't take the information and put it in your file. It also comes in where it's basically locked, so you can't accidentally select something and drag it away. It'll always snap back into its location. So that is super nice. And you know, if I was to just detach this and run import and just do I was just to import the site line work, you'll see that it brought in the same line work, but now these are all layers that have been brought into my layer tab, and you can pick those up and move them. I don't like to do the import straight from like CAD or Civil, because sometimes you're working with 300 different layers and it'll really dirty up your kind of Rhino file. So I'm going to undo that. I'm going to go into work session. I'm going to attach that line work. And what's nice is like all that line work lives in this grayed out area. You can't move it. If I wanted to detach this, you can just simply click this and detach. And as you can see, all that information left my Rhino model. This is really nice when you're working with architects who are exporting their building information in Revit, because those files can get extremely heavy, and I don't like to pull them in my Rhino file, because then it can become unusable because there's just so much information that it's trying to process. So that is just a quick example of work session, and I'll show you kind of how that works with architecture. So if I do work session and I'm going to attach the site massing file that I sent, and as you can see, that site massing was brought in a separate work session component. You can turn it off, you can turn it on. It's really nice, keeps your model kind of low file size, and it makes it very workable. So once you have your surface, and this surface is one that I think is ready to go, you can start to split that surface to start putting things on different layers. So as you can see in this site line work file, there's building, there's roads, there's front of curve, back of curve. So all of those you're going to want to render differently because there'll be different textures. And what I'll do is I'll just select these objects. I'm going to make this a working layer, and I'm going to make that working layer red. So I am going to select the back of curve, front of curve, select objects, extrude, and I'm going to extrude those curves through that model. So what you can do from there is take this and type split, and then you can select your cutting objects, which will be your curves. And you can drag those, press enter. And it'll take that surface and it'll split it with those curves. As you can see, some of these didn't split, and I'll select these. And what that means is that these weren't closed polygons. So that's pretty key when you're running the split command in Rhino. If they are not closed, if they are not closed, it will not allow you to split. Sometimes you're just going to run it a couple times. If you're trying to split a lot of objects at once, that will take a lot of memory. It'll take a lot of processing time. So here's just an example of, here's we know this is a closed circle. If we extrude this, I'm going to make it not solid so you can see. If you split this surface, it'll split it correctly with that closed surface. But say you have a series of not closed polylines like this, and you try to split that surface with unclosed polylines, it will say split failed. Objects may not intersect. So it has to be closed polygons to split. So from there, you can just go ahead and make some, make new layers, and you can go ahead and click on your curves. Change those all to concrete, as they will be concrete curbs, and you can see that they're rendered black. I'll make them red so you can see a little better. And as you can see, the curb line work is there. So from there, I'm going to just go ahead and select my asphalt layer. I'm going to extrude that, extrude curve. I'm going to extrude that through, and then I'm going to do the same thing. I'm going to take it and I'm going to split it with all that information. Then I'm just going to delete all this extra topography because it's erroneous. We're only going to do these 9 blocks. But as you can see, your roads are in there now, and I'm going to make a new layer and make this asphalt. Change this to that layer. So everything is on the same plane right now, and curbs are 6 inches tall. So I'm going to take this, and in the Z direction, I'm just going to move that down 6 inches. I accidentally hold these street markings in there. I'm going to move those down 6 inches as well. Street markings white. Change object layer. And I'm going to change the display color on that so you can then see they are a different color. So from there, you can see that there's a gap in your curbs between this and the road. You can select your concrete, and then you can extrude surf, and you can extrude that down 6 inches. Now, as you can see, your curbs are 6 inches tall and your road is 6 inches below that. So here's your blocks. They're 350 by 200, kind of a Denver block. From there, you can select more of your line work. I'm going to do pave paint, select objects, unlock that. I'm going to extrude those objects up. And I'm going to select everything here. Again, using split. Select these cutting objects. And I'm going to split that surface with these objects. So as you can see, you're starting with a surface, you're kind of dividing that surface into its separate components and then assigning them to different layers. And that's really kind of the basis of how I model sites. and it's pretty efficient at, you know, going from this file to a rendering software. This is taking a little while because there's a lot of information that it's splitting right now. Um, Hey Tyson, yes, work session does take the elevation of the line work. So you can work session in civil 3D topography, and it'll come in at the right Z elevation. So as you can see, it split that surface um, based on those extruded shapes. And I love gumball because it's really easy to move stuff. So instead of selecting each one of these individual squares, I'm gonna just pick this up and I'm gonna move it, you know, 2,000 feet in the X direction. And I'm gonna go ahead and go to top view, turn into shaded. And as you can see, it becomes a lot easier to just do these wholesale selections when you aren't kind of battling another surface that you could potentially select. So I'm gonna go ahead and grab all these. I'm gonna go and put these on the street markings white layer. I'm gonna turn those off. It looks like it duplicated some of them, so I'm gonna go ahead and just delete these. Great, so we got our crosswalks, and then we'll probably need a new layer, street markings yellow. And then I'm gonna just make this yellow. Grab these, and these are kind of your center lines. I'm gonna change those to that layer. Great. And then I'm gonna actually take this and move it back 2,000 feet. As you can see, all these things have been put on their respective layers. And actually just change the street marking to purple so we can get a good view of that. Great, so now we're starting to get our streets in. I'm gonna go ahead and grab the concrete layer from my work session. I'm gonna extrude that. I'm gonna take this surface, type in split, select cutting objects. Great. Sometimes if it processes a lot, it'll default to wireframe again, so you can just go ahead and change that back to shaded. But as you can see, we've got a series of split surfaces. You can grab and just select. Change that to the concrete layer. And there's a couple that didn't make it, so I'm gonna just manually select these. Sometimes you gotta run it twice if you're doing a lot of splitting at once. And then I'm gonna grab these surfaces, type in split, select cutting objects, enter. Great, so it split those. And then I'm gonna assign these a different layer. It's on concrete. Then I'm gonna grab just did select duplicates, cell dupe. I'm gonna delete those. It's sometimes it'll duplicate faces. I'm gonna go ahead and just put these on the layer again. Then I'm gonna grab one last thing, which is the asphalt layer. Take everything, split. So when I'm making these models, as you can see, I'm kind of going through layer by layer and splitting them. It's good to think about kind of an order of operations of, splitting your larger things first and then going into more detail. If you try to do everything at once, it can become very complex pretty quickly. And it did default to wireframe. I'm gonna go back to shaded. go ahead and grab these kind of alleyways. I'm gonna put these on asphalt. Great, so now you can see that all these things have been assigned to different layers. They don't have any materials set, so if I go into rendered, you'll see it's just a white rendering. But if I go to the materials, I'm gonna make this material import organic grass bright, make this concrete, use new material, import, textual wall, concrete, make it concrete light, take asphalt, import, go to exterior, hardscape, street asphalt. It's nice that Rhino has all this stuff kind of built in. Paint, make this white. Make this yellow. Great. Then if I go into the rendered view, you can see that, you know, Rhino has started to model these things. And you start to get kind of your asphalt, your grass. If you want to change the resolution of the grass because it's coming in small, you can always go in here and click this and then change this to a different size. And as you can see, the grass got a little bigger there. So this is kind of just a good way of looking at your model pretty quickly. It's also, if you're bringing it into Lumion, these materials will actually be brought into Lumion, and it'll allow you to kind of change that material texture in Lumion. But I'm going to just switch this back to shaded view. And there was a couple things that didn't split, so I'm going to just do that manually. As you can see, I'm going from point to edge, and I'm just going to pull this up in the Z direction and then drop it so it's splitting through that surface. If I type in split again, you'll see that it actually just split that. Change it to concrete. Great. So now we've got this. I'm actually going to put all of these parcels on a concrete layer because it's kind of where your buildings are going to be sitting. So change object layer, so concrete. I'll go back to rendered. So what's nice is if you turn back on your work session in architecture model, you can start to see that in renderings as well, in a rendered view as well. So this is just a quick way of doing some site modeling, and let's just explore kind of this park element here in the middle. Say we wanted this to be like a mound. You can go ahead and on your working layer, I'm going to turn to kind of cyan. You can grab this surface here and you can rebuild that edge with duplicate face border. As you can see, we've got a curve. You can offset that curve 30 feet in the center. You can offset that 20 feet in the center. Didn't like that. So I'm actually just gonna go into the plan view and draw just a similar shape. You can see that shape was drawn at the 0 in the Z axis, but I want it to be projected to this surface you can type in project. And in your top view, click that. And as you'll see, it just got brought to that surface. From there, I'm gonna just select these and I'm gonna bring it up 2 feet, deselect, bring it up 2 feet. Great, so now you can see this is like topography. You can, if you wanted to manually adjust the surface, you can turn your control points on. As you can see, it's kept all the information from its original surface. If you wanted to change that, you can do shrink trimmed surface, and then you can select this surface. And as you can see, it'll shrink that those surface points to that boundary. Then from there, you can go ahead and you can like manually adjust. The issue with that is, as you can see, this edge here has now become visible or just open. And when you're rendering, it'll be open in the renderings. So that's why I mentioned, like, I try to get the topography perfect beforehand, because if you start to manipulate this after the fact, you'll get that splitting, which is not what you're going to want to see in a rendering. So a way to mitigate that is, if I wanted to just draw a berm, and I wanted to see what that would look like, I would take this and I would just make a berm separately and patch it. Oops, that was too high of a surface span, so likely want to change this to lower. As you can see, it now patched this berm based on those contours. I'll put that into the grass layer. And then you can take the surface and you can trim whatever's underneath. So now you're left with your berm. So if you're working on a surface and you said, hey, let's explore what berms look like, I wouldn't manipulate this surface because, again, you'll get creases in your model. I would just make a berm separately and have it a separate piece. So I'm going to go ahead and do that here with this hill. One more thing to note, you can rebuild this surface by typing in rebuild, and you can change the X and Y grid points. So I'm going to change this to 20 and 20. And as you can see, that grid just got denser and we have a lot more points to edit with. So if you're just working in kind of the middle of the surface, it doesn't split it, but if you're close to a seam, it'll definitely create some issues. So that's just kind of working with that topography. Here, I'm gonna grab these 3 kind of topo lines. I'm gonna run patch. And as you can see, it patched this hill. I'm gonna take this, I'm gonna trim, and then I'm gonna trim this surface. So it didn't completely connect. So instead, I'm gonna go ahead and pull this up in the Z direction, pull this down, and I'm gonna utilize this to trim that surface. From there, put this on the, change this to grass, put this in the grass layer. And as you can see in your rendered view, you start to kind of see that hill taking form. So from there, I'm just gonna say, we'll just make these, this is your central lawn area, kind of in the middle of your urban downtown. This kind of reminds me of like Santa Fe or something. But say we want this to be a playscape and this to be a skate park. I'm gonna just move this to asphalt, and then I'm gonna make this a play surface. put this on its own color, change object layer. I'm going to make this a new material, and I'll just make it a salmon plaster. As you can see, you've got your plaster, you've got your concrete. I'm going to go to shaded here, and we'll just, I'll make this a new layer called play orbs. We'll just kind of fake in some play structures, and like we discussed in the first tutorial, we're just going to start with a basic sphere with a diameter of 3. And I'm just going to put that into the play area, make this one 2. This 1. And then I'm just going to start copying these things, moving them around with Command C, Command V. Moving them up a little bit so they're kind of intersecting. I'm going to turn my grid snaps off and then just move them up so they're not all like completely submerged. Some of them are, some of them aren't. Great, so these kind of remind me of the target bollards that kids love to play on, and so that's just some, we'll just put that in as some of the basic play elements. Over here, we'll just go into our concrete layer and we'll make a couple rectangles. Maybe it's, you know, 1.5 feet tall. I'm going to take these and I'm going to actually just embed them in the topography a little bit. Copy this, scale 2D. Make this one a little larger. Say you wanted to make like a rail to skate on. You could do intersect, and that'll actually give you that line to start modeling with. I'm going to put this on working. Great, so now you have a line that's conformed to that surface. What I'm going to do there is take that line, I'm going to trim the extra information away. So I just have that line. From there, I'm going to draw another line. And in the front view, I'm going to make it 2 feet tall. Press enter. Copy that line back. Move this up 2 feet. And then fill it. And the radius to 1/2 foot, 0.5. And I'm going to fillet that line. Unable to fill it. Make sure that it's on the end point. There. So now we have kind of the 2D line that'll make up the 3D railing. I call this metal. I'm going to run the pipe command, and I'm going to make this diameter 2 inches. As you can see, it just made a railing with a radius of 2 inches. I'm going to change this material to a polished aluminum. Okay. And I'm going to make those clay orbs a unique lavender. And then if you go into your rendered view, you can then start to see these different kind of skateboard elements, that railing. And then you got your play orbs over here, which is pretty neat. So, you know, this looks good. It's pretty quick, but say we wanted to bring it into Lumion. What I will do is I will make an export L, because Lumion likes to work at 000, much like architects in Revit. And you know, we know that 000 is pretty far away, and Lumion actually will not render that very well. So I always make an export L kind of adjacent to our model. I'm going to go ahead and just move this one a little bit closer. So then in Lumion, your 000 will be right here. I'm going to take this and I'm going to make sure that my architect's model has the same origin point, and you can go ahead and save that. And then as you can see, this is a work session. This is the architecture model, their previous export L. If you type in work session, you can actually update available. You can just click update. And as you can see, it just updated with that new origin point. So from here, you can select everything. You could do file, export with origin, and you can click the intersection of that export L. I always lock it so it doesn't get moved. And then you can export this as a culotta file, which is the file format that Lumion likes to use. So I'm not going to go ahead and export everything, but I do have a Lumion file pulled up that was pre-made. As you can see, you can go in here and start dropping in entourage, and changing materials, and you know, dropping in some kiddos. And then you can render these things super quickly. You can start to evaluate your design decisions. You can, you know, bring this up for presentations. So that's just to show you, you know, how quickly you can go from a 3D Rhino file, or, you know, model a quick site design with some buildings, and bring that into a rendering software. So that's just kind of showing you some of the power of these programs kind of working in unison. There's a couple more things that I would just want to show that I use a lot, and that's a few things. The first will be clipping plane, and this is a good way to start cutting sections through your model. And what I'm going to do here is just make a generic plane. I'm going to move it so it's this way because I want to cut my section through this way. I'm going to just type in clipping plane, and I'm going to use 3 point. So 1, 2, 3. And as you can see, it's clipped my entire model out. If I want to flip it, I can do that by clicking rotate 180. And then you can start to utilize this to start cutting sections of your model. This is a super powerful tool if you're looking at just things in 3D. And then if I turn on render, you can start to see how this becomes a powerful representational tool. And you can just start cutting sections all over your model. So I find this to be super useful. I also utilize this command all the time if I'm trying to come up with like cool diagram looking things. It's make 2D. And I'm actually going to set this view to isometric. This looks pretty good. And I'm going to just run a make 2D command, and it will select these objects to draw. If you press enter, and then you can mess with all these settings. I'm just going to do maintain source layers, and I want to make 2D the clipping plane intersection because that could be like a cool section cut line. And if I click OK, it'll take a little bit of time to process. But if I do zoom select the top view, you can see that it just took let me find my model here. It just took that 3D information and translated it directly into 2D. I'm gonna just put this on curves, change object layer. And as you can see, you can start to get this really neat kind of diagrammatic axon fairly easily from your 3D model. This can then be brought into Illustrator or Photoshop, and then you can start kind of populating with texture and entourage, and yeah, it's just a neat command that Rhino has to offer. You can also just in the clipping plane, you can also change its properties. So right now you can only see it in the parallel view, but if I was to put it in the top, you can see that since the clipping plane is over here and cutting through, if I turned it in the top, you wouldn't be able to see that. So those are just ways to manipulate that clipping plane. So I know that was probably pretty fast and covered a lot of ground, but I would highly suggest utilizing, this new tutorial that'll be out on YouTube as you're modeling in the future. You can always put this on its own layer and turn it off. But I would highly suggest using this, in using the tutorial and following along, kind of utilizing those files that I sent earlier if it's your first time. And, I find it's just easier to work at one's pace, and you could turn YouTube down to 50% speed and work alongside and ultimately get the same result. So yeah, that's really all I have for you all today. But please feel free to ask questions with the remaining 5 minutes.
And feel free to come right off of mute if you do have a question, as opposed to typing it in the chat. All right, Adam, let's shut it down.
Sounds good. Thanks for joining. And feel free to reach out if you have any questions as you start to dive into Rhino more. I'm happy to answer via email. So.
Awesome. Thanks, Adam. Hoping to get this recording on the link that I provided in the chat by the end of the week. So stay tuned. Thanks, everyone.